Well, first off, I just want to thank everybody for joining us today on the webinar. I know that during this time, there's a lot of people on webinars. Just to make sure you're in the right webinar today, this is the Carbon DLS and Protocam webinar. Just to introduce myself, my name is Ed Graham. Many of you may or may not know me, but I'm the Vice President of Additive Manufacturing here at Protocam. I've been here for this is my 25th year. I don't think I'm allowed to say 25 years yet because I started in December. So I have a couple more months to wait it out, and then I'll be a quarter of a century here at Protocam. Started in 1996. Protocam as a company was started in 1994. So I'm 2 years off of that. And we've developed and morphed into an additive manufacturing company. We started off with stereolithography back in 1994. Not many people were doing it back in those days, and it was our technology of choice. It was really the only technology of choice at that time. And since then, we've grown into a lot of different areas. We use a lot of different technologies, like you can see, stereolithography, multi-jet fusion, FDM, polyjet, and certainly now the digital light synthesis, DLS technology from Carbon. We are morphing into more of a true additive manufacturing company, producing end-use parts and going into low volume production. So that is why we got involved with the Carbon DLS technology. So at this time, I'd also like to welcome a really great guest that we have, Mr. Jason Lopes. And for those of you who don't know Jason, I'm going to read you his bio. So Jason started as Carbon's first beta tester of its technology in 2014 as the former lead systems engineer with Legacy Effect. Jason helped create some of the biggest Hollywood blockbusters of all time utilizing additive manufacturing. Jason's credits include Avatar, Terminator, Genesis and Salvation, 2012, Thor, Iron Man 1, 2, and 3, Cowboys and Aliens, Real Steel, Life of Pi, Captain America 2, RoboCop, and Pacific Rim, amongst other successful TV and film productions. That was a lot. That was a lot right there. And you can see in the background of Jason, if anybody's noticing, he has a lot of these characters from these films that he's helped develop. But after leaving Legacy Effects, Jason now helps companies leverage additive manufacturing and educates all spaces of 3D printing. Jason's a strong advocate of 3D printing, which has proven to be an invaluable tool in his production workflow, along with 3D scanning, 3D design, and 3D modeling. He's been operating numerous 3D printing technologies for a number of years to assist in the production of stunning visual effects and products, and was awarded 3D Printing Industry's Maker of the Year in 2017, the DINO Distinguished Innovation Operators Award in 2012 by the Additive Manufacturing Users Group. And since 2017, Jason has held numerous roles in the company, including production studio lead, and is currently the partner development engineer. And aside from that incredible bio, I've worked with Jason and known Jason for a number of years, and by far he is the most approachable, modest, really just genuine great guy. So I'm really happy to have him with us today. And Jason, I'm going to turn it over to you.
Thank you, Ed, and thank you, Protocam, and thank you to the audience for everyone for being here today. This is what I really like about doing webinars, especially with a company like Protocam. We have a lot of fun. We enjoy what we do. It's a lot of passion what we do. But first and foremost, it's shown in the quality of the work that comes out. I think it's very important to love what you do, have that passion for what you do, and show it in the quality. So today we're going to be showing you an introduction to DLS. And I want people to understand, you're going to hear the term DLS a lot today. That's our process coming out of Carbon. It stands for Digital Light Synthesis. So I'm very honored to be able to present alongside with Protocam, as well with representing Carbon, to show what this offering can do coming out of a really high-end partner like Protocam. So there's one thing to understand. Up at Carbon, we have what's called the Carbon Production Network. And this is an ecosystem of all of our advanced partners that we wanted to have out there helping to influence the adoption of 3D printing, but more importantly, low volume production, and really show that we can take things into a production mindset. So in our network, we really look for quality over quantity. We hold a lot of pride in all of our partners that are extensions of us. And if you just look here, this really, really hones it in. You know, going with a partner like Protocam, you know, we look for the ISO certifications, the ITAR certifications, and it's just nice to know that we have that quality that could deliver parts to standards, to QC standards, and all different processes to really help push production along. We consider our partners to be extensions of us. Up at Carbon, we are not like any of the other big players in the industry. We do not offer print services. We want our print services to be offered by our network to be that true representation of us. So a little bit about Carbon as we dive into this. You know, 3D as it's meant to be. We like to show a lot of things. We're a very heavily marketed company. However, there's case studies behind what we're showing that this is real. We are getting into production every day. And if you look at these verticals at the bottom on this slide, in automotive with companies like Ford and Additive, we have parts on cars. We have parts on Lamborghini cars. We have parts on Ford cars. You name it. We're doing all areas of production, whether it be low volume production, bridge gap production, or serial production. We've proved that it's possible with an additive technology. In the consumer space, I think everyone here is familiar with the Adidas sneakers, as well as the Ride Out football helmets, and more recently, the specialized bike seats. So we could do really amazing things combined with design and our materials. In dental's been a very big space for additive manufacturing. However, we've really flipped the game with our thermoforming applications at scale, and even having a solvent-free cleaning workflow and resin recovery as well, to even go better into economics in a space that's already existed. We've kind of flipped it on its side and really propelled it even further. In industrial, we have some examples of some of our materials actually going up into space. In life sciences, a great example of what we've done is during the COVID-19 pandemic, actually using one of our third-party dental materials and releasing nasopharyngeal swabs out to the market at scale. So it's really, really exciting. So what is Carbon DLS? Digital light synthesis. Like, there's a lot of technologies out there, but how does it differ? If we look at the circle on the left, we can look at heat-based technologies and filament-based technologies, such as FDM, fused deposition modeling, and SLS. And we would even put MJF in this category as well, powder-based technologies. These produce really, really strong parts. However, maybe a little bit lower on the surface finish level of detail really isn't there. There's limited material options, and a lot of times the parts can be porous. On the right-hand side of the equation, we kind of have the exact opposite. We have our polyjet jetting technologies and SLA, as Ed had mentioned earlier, stereolithography, that have been around for a long time. They produce very nice looking parts, however, very low UV stability, limited material options, and once again, you're just not going to get those mechanical properties of a true end-use part. So what does Carbon do? We bring the best of those worlds together into one platform called digital light synthesis. It's cured with LED and oxygen. So in our process, you can get fully dense parts, highly detailed parts, UV stable parts, and we have a very wide range of materials, and even more coming out on the roadmap, more and more based on industry and partner feedback. So we can give you high performance materials with excellent surface finish in one system. So I'm going to play this video that shows our process. And first thing you'll notice is the build platform lowering into our window cassette. Now, where our process difference is from other technologies is we're not a layer-based system, so we're not sending slices to the machine. Rather, we are converting the geometry and the print setup into an alpha channel movie. An alpha channel movie is kind of like a bitmap movie, black and white image sequence over time, played at a certain frame rate for the material chosen. So all of the UV is coming up through the white part of the movie, and anything that's black is blocked out. And if you look in the top right video, you'll actually see the part in this example is printing continuous. So you don't see any up and downs. We're going straight up in the Z, and we're able to build a lot faster, but more importantly, open up chemistry for new materials. So a more close-in example of what we just watched, the part is right in the middle of the screen, and you can see there's been contrasting agents added. The resin actually flowing into the dead zone on top of the window, getting solidified into that part. What that does is it allows us to build continuous and not have to do a layer by layer approach, leading to anisotropy parts. We have isotropic parts, fully dense parts, which allows us to come up with new chemistries. We can use two-part materials, urethanes, epoxies, and we can even go into sterilization methods that may be needed in healthcare, life sciences, or even in the automotive market as well. So the Carbon platform consists of what I call three pillars: hardware, software, and materials. Our hardware is really, really advanced, and we've tried to simplify it so that an operator can just do her or his job without having to worry about calibrating the machine at a certain interval, having to do their own preventative maintenance. And even when it comes to a material change, it is seamless. It's literally a drop-down window, and we can switch into a new material and just dispense said material to begin that job, making it really easy. Our software controls the hardware, which keeps a massive uptime on this technology. But more importantly, we've actually introduced design tools into the software at the printer level to allow customers, partners to really do advanced things rather than just make it part. And we'll get into a little bit of those offerings that come into the DLS platform at Protocam. And then last but not least, materials. We really have opened up the chemistry of what you can do in an additive system. I've been doing this for 16 years, and the minute I got my hands on some of these materials through this process, I didn't look back. And it made me very excited because my whole career was about trying to go direct manufacturing. Having to introduce another process in to take it from a prototype material and cast it into something else, just really with my deadlines and what I was trying to accomplish, that wasn't what it was for me. I wanted to utilize and exploit the technology as much as possible to be an extension of myself, but to have materials that would survive out in the real world like everyday materials. And Carbon has really opened that up. So if there's anyone on this call today that really needs to go deep on materials, testing that we've done, some specific special testing, please reach out to Protocam. We have access to all of our materials divisions at Carbon. That's what the beautiful thing is about these three pillars. All of this lives under one roof, and our partners have full access into this to go deep for any type of application or program need. So a little high-level overview of our materials. If we start on the rigid side, we'll start with the two RPUs on the left. We have RPU 70. It's very comparable to an ABS material. It's actually Carbon's first flagship engineering material to come out of the gate when they went commercial. And it's led into a newer material called RPU 130, which is comparable to a nylon or a propylene. You can think of it as an ABS with a higher heat deflection with a little bit of flex added into it. On our next one, we have what's called CE221, which is cyanate ester. It's comparable to a 15% glass-filled nylon 6. This is our high temperature material. This can withstand temperatures up to about 230 degrees Celsius out in the real world. Our epoxy family is a very common one in industrial applications as well as automotive applications. That's EPX82. It's comparable to a 20% glass-filled PBT. That's actually a fuel cap for the Lamborghini Ursa. It's one of their SUVs that's actually a production part on that car. Then we have FPU50, and I actually have a slide down the line in this presentation that shows a good example of this. It's called flexible polyurethane. The easiest way to think of this material is living hinges, caps and closures. Our next material is UMA 90. It's a little bit of a tongue twister name. It's urethane methacrylate. This is our prototyping material, if you will. It does not need a secondary step of baking in an oven. and it comes in CMYK. Now, this material is really interesting because it actually is about 16 to 22% stronger than a lot of prototype materials that are out on the market. And you can actually use this on the production floor, jigs, fixtures. It's very quick turn to produce these type of parts in a pseudo production environment. Our next one that I'll tease before we have some slides on it is Loctite 3D IND 405 Clear. It's comparable to a polypropylene. This is actually a material that we partnered with Henkel with to bring to the Carbon platform, and it's a third-party offering. Once again, single cure material, does not need the oven step. You print, clean, and UV cure, and you have parts in hand. The bottom left are our elastomers. I think that's what Carbon's really known for. We have two versions right out the gate, EPU 40 and EPU 41. One is for impact absorption and one is for energy return. The easiest way to remember the differences between these two elastomers is if you think on the 40 side for impact, you could think of the Rydell football helmets. They're going to absorb and take impact. The opposite end of the spectrum, think of the Adidas sneakers. They're going to give that energy return in performance. Now, the caveat here is through the power of lattice design, you can actually manipulate variably the properties of this material and get even new results entered into the design space. So there's a lot of exploration to have there as well. And then we have a silicone type material, Sil 30 it's called. It's not a true silicone, it's a silicone urethane. It's biocompatible. It's great for soft touch buttons. I actually utilize this material a lot, combining with other carbon materials, with rigids.
Again, we are mostly known for the elastomerics, but what we're really excited about is all the different rigid geometries that we're working on with partners like Protocam.
This is what's really cool. This is our first third-party partnership with a material, and it's a clear material that a lot of people have been asking for a while. I've been asking for. So if you recognize these bottles, you'll see what's really neat is this is the first material third-party offered on the Carbon website when we had this partnership. Protocam actually signed up to be a partner at the same time I was working behind the scenes with Henkel on this material, and I thought of no better fit to help us bring this to market. So all of this imagery that you actually see on the Carbon website for this material actually comes from Protocam. So what's really neat is as we were ramping them up to come online to be our partner, we immediately handshook them with this material, provided samples, and let them fully finish them out and show us what we could actually do with this material. So as a nice overview, you know, it comes off the machine frosted like any other additive material. It's great for functional properties, semi-rigid materials, high elongation, and it really has a best-in-class toughness. This material only sits a couple specs down from our ABS engineering material, and it's a one-part resin, so it's really, really, really easy to work with. But more importantly, what can you do with it? And you put it in a companies like Protocam's hands, and this is what you get within days of them playing with the material. So you can really do some nice advanced things for fully clearing it out, for actually tinting it and coming up with looks. If you couple this with some design parameters of texturing and even latticing, there's some really neat things that I think we're going to see in the not too distant future around this material being printed in the Carbon process. So some of the target applications are light and fluid routings for prototyping, food and beverage for small kitchen appliances in the prototype world, jigs and fixtures. Once again, this is a very easy material to work with, and it's actually really exceptionally strong for a single cure material. Low temperature tooling for high impact is actually done very well in this material as well. Housings, enclosures and covers, and vibration impact resistance. Really neat material to work with, and printability is key and perfect. You can get an idea of where it sits out of all the clear printing resins that are offered throughout all the OEMs, and it sits up there pretty nice. So it's really, more and more case studies or everyday uses are being utilized in this new offering. If I'm not mistaken, we are only about 2.5 months in of actually offering this material, and it's one of our most successful materials after launch to date. Another very exciting material too is RPU 130, an industrial in the automotive world. Tough and temperature and impact resistant polyurethane. You can see here for yourselves the properties on this, and as you see some of these properties, I think it's really important to know we haven't seen properties like this in additive ever. We can get close in powders, but now we're limited to, not too many materials. So we're really trying to, bring to market from all of the work that we've been doing with big players on the OEM side for serial production. What are the true needs? What can we get to market? And this is what makes it very exciting for me. Another one that's coming to market is a cousin of our EPX82. This is our first foray into a V0 material, and it will be available in April to the public. However, companies like Protocam, being one of our partners in the network, have access to this now. So if anyone wants to see our first V0 material and have some benchmarks done, you can do that through Protocam, and Carbon, myself, and Lisa, the account manager, would route that through and get benchmark and samples in your hands. I've actually brought a low volume production in this material to market a couple weeks ago, actually. We went through all the vertical burn tests, material was approved, and went into low volume production in an example. And printability is key. It's really nice. It's accurate. And once again, this will be fully released in April. However, Protocam can get you benchmarks today in this material. And then even further down the line, in development, we have an advanced thermostat, really coming out of the automotive connector space, underhood connectors and polar fluidic routing. We can get benchmarks in this as well as we move, getting closer to commercialization and final formulation. But you can see the tensile modulus here, the tensile yield strength, and the elongation at break. More importantly, the deflection temperature. Pretty impressive materials coming to market. And what I really like about these advanced materials is it's one thing to have better materials, but it's another thing when you actually are listed on Prospector. I've learned a lot in the past 3 years from my counterpart that's on this call, Lisa Lehman, about the injection mold market. Done a lot of studies in injection molding and explorations over the past 3 years. And I know this resonates a lot in traditional manufacturing, when you can show materials that were gone through the testing and get listed for biocompatibility, sterilization, V0 chemical compatibility, and UV stability. It really shows that Carbon, in an odd way, is more of a material company than we are a hardware or software company. And I don't say that lightly. I mean, to bring these materials to market, that two-part resins that the world's never seen before. I see the heavy lift that we put to it every day up at Carbon, and the development of these materials and pushing it through from all that market data and customer feedback. And I look forward to even more materials making it onto Prospector in the future. So what's the digital light synthesis sweet spot? There's many ways to look at additive manufacturing, 3D printing, and just what I really love about this machine being at Protocam is you saw on the opening slide all the other offerings. I look at this as no different than opening up my toolbox in my garage. I have multiple tools to do a job. And when I see the arsenal of all the different technologies and Carbon being in there, it really just opens up the world of how can we use this for advanced things outside of default? Can we bring in different material properties to other technologies? And we can do a lot of really neat things that just haven't been possible before today. But one of the biggest strengths that I always say in Carbon is part consolidation is huge. This is a very big win. Can we take something that is X amount of parts, has a couple of items that are sourced and needs hand labor to be put together? Can we relook at that design and consolidate down to one part that performs better? We've gotten time back up front that we can really put into the design and making a better performing product and avoiding cutting a tool. In this example of this part consolidation top right, you can see the original part had 3 parts, 8 screws, a couple O-ring seals, tooling, but more importantly, it had hand labor to put it together and it had multiple points of failure. The redesign for DLS is one single part that performs better and is economically feasible to swallow for a low volume production, not having to worry about that locked tool. So it really opens up product development in a whole new manner of near real-time interaction and feedback. Small parts, we can print big parts. I like saying small parts because when we're talking about production, we want to be able that we can get throughput per shift. When we start understanding quantity per shift that we can do, it really opens up the world of economics and a good understanding how design constraints affect the cost of a part. And you can start understanding and dropping down through design and getting a good understanding of the economics around additive in general, which works really, really nice, and it becomes a very compelling story. And also, smaller scale parts tend to need less of sacrificial supports, overhangs and angles. We can actually push the limits a little bit further in smaller scale geometry in our process than rather one big part that fills up the whole envelope needing to be supported and driving up the economics. Textures and latticing are huge. I'll get into that after this slide a little bit. We can mimic right at the printer any type of mold tech callout, noise, with leather, geometric patterns as well, positive or negative. Lattices. We've made latticing very, very easy, and Protocam has access to this. We have our design engine, Lattice design engine, which actually takes a solid design space in and lets you choose a few different lattices and properties and output that as an STL to be printed. We do really well at fine features and cosmetic surfaces, as you can see in the pictures below. Our printer by default prints at 100 microns. You can print at 50 microns and even go down to 25 microns if needed. And air and water up to 230 degrees Celsius through our cyanate ester, our CE221 material. So a little bit digging into texturing. This is a default slide, obviously, of some of our texture patterns that are generated through our software right at the printer level. We can do really, really nice things here and really take it to the next level. Without a texture, our parts can really hit very close to a Class A surface. However, you just add on any part of the geometry a texture, and oftentimes people think it's an injection molded tool. And you're going to see later in the presentation during the giveaway, there's a great example of this, and it just blows me away sometimes when I look at a part, and really to my eyes, I have to second guess sometimes and say, this is very comparable to an injection molded part. And I think that's something to be said where this technology is going. People are used to what they are used to seeing in their hands, especially if all you've been doing is traditional manufacturing. I think when we put parts in injection molders' hands and people that are just not familiar with 3D printing, they're expecting to see that, you know, the stair stepping on sidewalls, basically all of the variables that we've come to know in 3D printing, what I call the fingerprints of the technology. Oftentimes in carbon, you'll look at it, you'll think it's an injection molded part. So this is what's really neat. And this, you know, goes down to, I'd rather show a true example of texturing, and everyone's going to see this today as well and have a chance to win this. But right here, what we're looking at is one of Protocam's texturizing jobs. And this image here is actually on the printer. You click on the surface of the part, and then you choose the type of texture that you want. And you can play with it with depth. You can actually go higher, lower. You can go into it, cut into it, or you can go above the surface, and you can adjust the tile spread as well to get more pronounced or more subtle. So here we are, we see some texture laid up in software, which is nice, but as soon as the print finishes and they clean it up and cure it, this is actually that final product with that texturization right through the carbon ecosystem. What's really, really nice about this is I think everyone in this webinar will agree, this part looks gorgeous right off the machine. There is zero handwork to this except for assembly and getting rid of supports in areas that needed support. It looks absolutely amazing. And I think more and more people see every day parts when we send them to them, and they say, are you sure you didn't send me an injection molded part? And I laugh all the time and I say, no, I'll show you the full software setup of it. And people are just like, oh my God, this is really amazing. I could just use that texture tool. Forget about the print. What's really nice about this offering at Protocam is our texture module, it doesn't have to stay in the carbon ecosystem. So if anyone is on this call and wants to see textures in your application or your prototype calls out for the SLA process, you can still utilize this software offering and apply that and have it done in other technologies. We don't limit you to just stay on the carbon technology with this texture offering. You can output it and go anywhere you want with it and see the results for yourself. Really, really nice.
Jason, it's fully functional too, so there you go.
Oh, I love that, Ed. That's great. Really, really nice. And once again, a drawing can come through for a part that was designed X amount of time ago, have that mold tech call out, and Protocam should be able to cross-reference that into our software and actually come up with a very similar result as that call out. Second to none. And I'm very impressed with this, guys, at Protocam. Like, I actually want one in my hands. It's, you know, having to give it away, kind of little sad face here, but I'm happy for whoever receives it. Another great offering through the Carbon ecosystem, and I think everyone on this call will know, more and more you hear Lattice terminology. And historically, to do a Lattice, you'd have to hire a graduate that has a degree. You'd have to invest in a very powerful workstation. You have to pay for the software. And it was very unique to that specialist to drive it. And it would take a very long time to do so. Well, we've added this module right into our printer software. Protocam has access to it. So you can take a solid design space very easily, as you see in the screenshot on the left. You choose your material. We have 5 different lattice types, and you can populate your design space with any one of those 5 different lattice types. Not only can you do that, but you can also variably fill it from a smaller cell size to a larger cell size right in that same design space and do some really advanced things. Now, you see a lot of latticing being done on the elastomer side of things coming out of carbon. What I really think we're going to start seeing a lot more is latticing just for lightweighting on the rigid side of things. Think about that, you know, prototype fan blade. Why does it have to be solid? We can skin it, have a nice lattice on the inside, decrease the weight, have the same performance and strength in the part. This is what the offering that you can be achieving with Protocam. And if anyone wants to dive deep on getting to understand how to utilize a lattice, I really encourage you to reach out to Protocam, and I can even join with Protocam and show you what we can do. And it doesn't need to be just a single lattice throughout it. We can go from a lattice to a solid zone in the file and really have a nice aesthetic look come along with it as well. So speaking specifically to healthcare, there's a lot of changes that are happening, you know, especially I've seen a lot going on, especially during this pandemic, as everyone else on this call has as well. So some of the global trends with the aging population and growth of emerging markets are feeding into the healthcare needs. We're able to show lower costs and just more access to this technology and how it can help life science organizations and how to utilize it. But more importantly, even if you don't have a need for it today, how you're doing it, I really encourage looking at how we can apply this. What's the value proposition just in our engineering workflow, even if we are going traditional? How can I use it as a bridge? How can I use it for learning for the company in the future? How can we shift some very low volume programs over to this way of thinking? And then if you look at the 3D manufacturing growth drivers, it's all innovative, personalized therapies, cost-effective solutions are needed, and all traceability through digital solutions. This is what's really, really nice, especially in the life science world of working with this technology and these materials. You can actually have surgeon, physician, you know, collaborating with you on a design, making a customized design for a one and done use case handle that's needed at low volume scale, and have that person really interact and making that better product without missing a beat. You can have parts in hand the next day and getting feedback for the next revision, second to none. And if you look at some of the types of devices within the medical industry, respirator masks, especially with our elastomeric materials, once again, biocompatible materials, so we can actually do a lot more things. Trocar handles, these are huge. These have been around for a long time. We can actually customize these and add digital texturing to them for better grip and performance. This access port, I really wish, and I think I'm going to do it soon, having a cross-sectional view of this piece of geometry. This is not moldable. This is an impossible geometry. All the routing and channels on the inside of this, you just can't be done in a traditional process. You can do this in additive manufacturing, but to have this be a single one-use part, you can only do this with a technology like Carbon DLS because of the materials. Surgical guides are huge. They're being customized every day and being made better from operation to operation. This is just an improving thing. And what's really nice about this is the surgical guide can be in production. You can get feedback, modify that geometry, output, and stay in production without missing a beat, and print them on demand as needed for low volume. And endoscopy tips, these are huge. Flexible structures plus sterilizable materials. We can do every form of sterilization at the moment except autoclaving. So if you would like to learn more about what we can actually do for testing the materials, please reach out to Protocam. We'll be able to answer those questions and get you all the information on it as well. So some of the real successes within that market, prosthetics, obviously huge, especially when you marry that with scanning, being able to do custom prosthetics on the fly, orthopedics, surgical guides, pediatrics, huge, once again, incorporating 3D scanning to an individual person for that custom solution, second to none. You can now incorporate lattice design into that, so you can have a strong part with texturing, more comfortable, but more importantly, dropping those economics to make it more palatable and understanding the costs within this world. Any device with a rapid innovation cycle, this is second to none. You're able to keep up with that innovation cycle and be ahead of that. And of course, high mix, low volume, always going to be a win here. Surgical robotics and imaging, huge, especially when you start marrying our rigid materials with our elastomeric soft touch material. And then lastly, disposable and limited use components to capital equipment, one and dones. This is happening every day. It's happening fast every day. You can hit nice production numbers and be able to carry out a better performing application through this workflow. Here's a great case study that comes out of the healthcare world from Becton Dickinson, BD. This is a great example for many, many reasons. I like to hone in on this design was done not intended for 3D printing. There was an issue with the tool of some sort, and they wanted to switch this over possibly to additive manufacturing because it was such a low volume requirement. Well, the operator looked at the geometry and just had one simple question. The back that you see in the diamond pattern in the traditional part was actually squares. So they were clocked 45 degrees into a square pattern. To print that one-to-one in carbon, it was possible. However, all of those squares would have needed to be supported and then hand labor to remove them. By asking a simple question, and what I've started saying the acronym MFP, which I call Modify for Printability, rather than redesign, can we clock those squares 45 degrees and turn them into a diamond? And then they said, yeah, that shouldn't be a problem. Why would you want to do that? Well, now we've made it self-supporting. By doing so, we've taken off about 11% of the cost per part due to not wasted material and hand labor for the final part. So asking those simple questions can really lead to better outcomes just in economics to modify for printability. Once again, not a full redesign, but we just want to make it so it works within the process of additive in the best way to lower and drive down those economics. The story that I've been told is after this part was produced, they showed it side by side with the injection molded counterpart up at BD, and no one could tell the difference between what was the 3D printed part compared to the traditionally injection molded part. So once again, a nice win. I think right here is probably, I think Ed will agree with me, the holy grail of a 3D printing torture tests. Can we do a living hinge? I shared this conversation multiple times a day with people. I really like the idea of doing a living hinge. In this example from BD, they used flexible polyurethane, FPU 50, and actually got 150 cycle times in their living hinge. This makes me really, really excited because now we're getting out of the world of a prototype into more of a functional prototype, leading possibly into production, low volume production of living hinge geometry. Now, I'll be the first one to tell you that a standard living hinge design that's been done traditionally will not work coming over to additive one-to-one. You have to do a little bit of design principles for the technology that you're using, but you can make a better performing living hinge by doing so if you're able to do so. And I'll show an example right now. So here, I put together this little slide last night, and there's a movie here I'll play in a second, but this is that FPU 50 material. You can see the specs at the bottom. The two examples are, that's a little housing that has a hinge to close, and then there's an advanced Velcro application utilizing Rhino and Grasshopper to generate these mushroom tip-like Velcro devices for being able to do a functional part in additive. Pretty wild when I first saw this. So Lisa Lehman, who's Protocam's account manager, is on this call. I took this video probably a year and a half ago at this point in the middle of the night. So it's not the best video because I was so excited about what I was able to see. This is a modified design, and I was able to cycle it right out of the gate over 250 times before putting it down. You'll see in the background of that picture, there's a whole bag of them. So I have a lot of them. This is not just the one and done. But more importantly than the living hinge, this was for a shampoo cap. It needed to hold, I believe it was 21 or 22 PSI. So in transit or carrying the bottle, it makes sure the product didn't spill out. And it actually has a snap fit as well on top of just being a living hinge. I'll hit play here. I don't know if you'll be able to hear it, but you'll actually hear the snap fit as well. So if you heard those snaps, that's the actual snap fit. So it's a true functional additive piece. Lisa and I showed this to someone when we were traveling through Ohio a year ago. And when they had this in their hand, the first thing they said to us was, we've been trying to do this on every additive system that we've purchased in the history of this company. This is amazing. We push this more and more every day. And if anyone's on this call that likes what they saw there, I really encourage, like, let's work together with Protocam and do some living hinges. I don't think this has been exploited a lot. I think there's more to come for this. And, you know, you have a wizardry like Ed over there that can give you some great design recommendations and really bring these things to life. So this is another story that I really like a lot. Because everyone's seen this application. If you've ever walked into one of those, not going to mention the name, but a very fancy coffee place, and you see them take the pitcher and go into the sink and clean out the pitchers real quick before they make another very fancy, expensive drink. That's the nozzle that's down inside of the sink doing all of the cleaning out. The legacy design was 6 parts, and it was sonically welded. So now we have a poor performing part because of the constraints of manufacturing. We have the assembly, we have the labor, and then we have failure points. So if you can look at a redesign, I know that's a heavy word, redesign. This is not a modification for printability on this one. This is a redesign. But if the customer is open to getting better performance and better value up front, this is second to none. So you can see that new single part design on the right-hand side. It's not just converted over to do the same performance. It's actually redesigned with FEA to get better performance. When this went out to the field after design for testing, it actually passed 1.5 million rinse cycles in the application to make it into production. I think that's pretty impressive, that bullet point right there. And it was 10x more durable than its previous, what it just replaced. Huge. We actually reduced the material by 30%. So you have that design freedom to not only make a better performing product, but you can actually drop down those economics even more. Really big win here. So some of our use cases, once again, concept and development, huge. We can expedite the design process and reduce that risk. Functional prototyping for bridge solution, eliminate that prototype tool. Very, very big, and more people are starting to adopt that workflow more and more. You could ask Lisa, we explore this a lot every day, multiple times a day. That's where the big win is. Low volume serial solution. High mix, low volume. Once again, we've been hearing this for a long time. We've proved it. Service solution, zero inventory, being able to order on demand.
So again, this is vehicle wide. These are all on the M2 platform, which is what we have through Protocam. So you can see here, and I know Ed, you really are big into the automotive segment here, so feel free to jump in. But you know, the connector space, we have a couple case studies behind this that we want to share with you. The badges and trim was a program that we did with BMW where they completely automated a cell, and it was really on demand. It was really that notion of get what you want now. And so when we look at automotive, traditionally additive hasn't played a lot in that space. I would think just because of material properties, you know, tight requirements, things of that nature. So again, these are all places that Carbon has parts on cars. I think the more powerful part of this conversation is really time and speed to market. And so what we saw when we used additive in some of those cases, it really cut down between, as you can see here on this particular timeline, going between 88 weeks down to 42 weeks. So almost a 50% savings in terms of being able to get to market. And all of our case studies for automotive are available on our website, but please utilize the strength of Ed Graham and his team there to walk you through anything that you might be thinking of that, you know, who doesn't have a customer that needed it yesterday and that they were too late getting, you know, behind on that. So that's what we love about Carbon, getting you there faster. One of the case studies is really Ford. We were the first automotive additive that went onto Ford cars. You can see the 3 parts here, but look at those testing requirements. I mean, you're talking about weathering, heat exposures, UV stability, even the flammability. So we utilized EPX82 for these parts, and you can kind of see up in the one on the kind of to the left, it's actually one of the parking brake brackets. But you know, these types of things can be textured. These are textured. They're serialized. Ford bought in very heavy with Carbon, which was really exciting to us. So just think about that, PPAPs, things of that nature. We really have been waiting for automotive to come around, and we were able to do that with not only Ford, but we also work with Lamborghini. We also work with some of the other big boys. So it is here, and it's here to stay. When we think about Carbon, we also think about like, what can it do for your business? So I think Protocam really saw Carbon, and I'll let obviously Ed speak to this, but it is allowing them to move faster. Ed and Jason and I talk quite a bit, and we think about, you know, hey, we have somebody that's looking at a SIL 30 application. They need to have these parts, you know, tomorrow. You know, can we get those printed today, get them done, and get them over to them? And it is a game changer, I think, personally for me. I know what it used to be like, and when I joined and went into additive about a decade ago, that was the power. And now here we are 10 years later, and it's just faster. We're becoming stronger out in some of these industries, like, you know, NASA. We have parts that went in NASA. I mean, come on, this is where it gets good. So with that being
the faster point, you know, exactly, Lisa, you know, to your point, you know, with any photopolymer type system, the speed at which this printer is able to produce parts is incredible. It's extremely fast and allows you to get through a lot of iterations in the same day.
And I look back to when you first came on board, and do you remember when we were doing a lot of texture examples together to show to one of your clients, being able to iterate multiple times within 1 hour and get them back in hand? They like what they see in the software, hit that print button, have more than just that example of showing. Really, really fast and dynamical.
Absolutely.
It's my favorite time, guys. It's giveaway time.
Is it time? All right.
I know, it's giveaway time. So Ed, walk us through what this giveaway is. I know, like Jason, I'm sad I can't be entered to win, because we're going to release a trivia question next, and the first person to answer is going to be winning this giveaway. So Ed, tell us more about it.
Yeah, so we, you know, we worked with a good customer of ours, Streamlight, a company we worked with for many years. And, you know, we felt that this was a great fit. The technology was a great fit for this application, the flashlight industry, and some of the ones that we've been working on with them. And the fact, again, that we can take this material, we can apply texture to it, print it, do no post-secondary operations to make it look like a production piece. And I know it, you know, it doesn't do it justice, but it's a beautiful part, fully functional. And again, incredibly fast. I think this part probably took about 4 hours to print. and it was done. And that's just because it, you know, of how tall it is, but it's an extremely fast print. So yeah, we were really excited about it. The ability again to have regions on it that do not have texture, other regions that do, be able to put logos on it, you know, kind of make it custom, if you will. So that was the beauty of it. You know, it's a standard product, but we were able to take it quickly and make custom modifications to it to fit for the giveaway. So we're excited about it. We really are proud of it, and I think that whoever is the lucky person to receive it is going to also be happy. It is the UMA 90 material. We did that just again. Jason had hit on this earlier, but the UMA 90 is remarkably strong for what it is, and I think it works really well for this part.
So Ed, how many total parts is that design, Ed?
What's that?
How many total parts is that design?
For what we printed for it, it's just the main housing is the main housing, and there's a part up here that actually holds the button in. So it's two components.
The other components are off-the-shelf components that go into it.
Yeah,
So
we actually worked with their team to just take the existing design. We didn't redesign it. We just applied some texture and did some customization for logos, but all of the fits, including, and I know it's very difficult to see, but underneath of this light lens is a very fine thread. And the fact that this part printed and this thread just threaded right on without any issues, no chasing, no problems at all. It was pretty outstanding for it to come off the printer and thread right together.
Nice.
It was really, really nice.